This is the 3.7 to 3.8 review, the free response question number 7, and calculators are not allowed. We're given that f of x is a log natural function, and our first question is, what is the domain of f? So we need to remember that the only things that screw up domains are division by 0, trying to put non-positives in a log, or negatives inside an even root. So if we look at this situation here, we have a denominator which could cause problems. We also have the insides of a log. So we can write that the domain is going to be all values of x for which this 2x over x plus 4 is positive. So if we look here, it's a fraction, and fractions are only positive if the top is greater than 0 and the bottom is greater than 0 at the same time, or if the top is less than 0 and the bottom is less than 0. So if we have both top and bottom are positive, we end up with a positive fraction, or if both top and bottom are negative, we end up with a positive fraction. So if I solve for x in each of these, I'll have x is greater than 0 and x is greater than -4. So the numbers that satisfy both of these conditions are only the x is greater than 0. Then if we look here, we can see that 2x is less than 0 and x plus 4 is less than 0, which would mean that x would be less than 0 and x would be less than -4. Well, the only numbers that are both less than 0 and less than -4 are the numbers that are less than -4. So that means your domain is all values of x that are greater than 0 or all values of x that are less than -4. Next, part B says we want to find the value of the derivative at x equals 2. So we've got to take the derivative of this function. So we can write, and I'm actually going to do this two ways. One of them is probably the easier way because we can use the properties of logs to rewrite this. So we'd have the log natural of 2x minus the log natural of x plus 4, since interior division is the same as exterior subtraction. So if I take the derivative, I'll end up with a 1 over the inside times the derivative of the inside minus a 1 over the inside times the derivative of the inside. So again, we end up with, excuse me, 2's canceling, and I get a 1 over an x minus a 1 over an x plus 4, which I can then evaluate at 2. So f prime of 2 would be 1/2 minus a 1/6, which would be a 3/6 minus a 1/6 is a 2/6 or a 1/3. The other way that we could do it is by neglecting to see that we have an interior division that is an exterior subtraction, and instead just doing the regular derivative. So we'd hit the log, which means that we'd have 1 over the inside, which is the reciprocal of the inside, and then we would multiply by the derivative of the inside, which would require the quotient rule. So we'd have low d high minus high d low over low squared. So if I simplify this, I have an x plus 4 over 2x times a 2x plus an 8 minus a 2x over an x plus 4 quantity squared. Well, since I'm dividing by an x plus 4 twice and multiplying it by it once, I can reduce that off. These 2x's cancel. This 2 will go into the 8 4 times, so I really end up with a 4 over an x times an x plus 4. If I now plug in 2, I will get a 4 over a 2 times a 6, which is a 4 over a 12, or 1/3. So either one of these methods would work and be legitimate for part B. Part C says I want to write an expression for the inverse, where the inverse denotes the inverse function. So on this one, Notice I'm not asking for the derivative of the inverse at a particular point. So on this one, it's our old pre-calculus skills, which are, can we write the inverse function? So if you recall, when we wrote inverse functions in pre-calculus, we would reset f of x equal to y, and then we would switch the x's and y's and isolate the y. So I'm going to do that down here, and we'll have our original function, y equals the log natural of 2x over x plus 4. I'm going to switch my x's and y's to get the inverse relationship, which I now have. And now my goal is to isolate y. And I can see that it's showing up in two places. So my job is going to be to use algebra to get those y's together and then alone. So the first thing I'll do is get it out of the log natural. I can do that by raising both sides to e, making both sides a power of e. When I do that, the e and the log will cancel, and I'll get a 2y over y plus 4. Now I want to get rid of the fraction so that I can at least get the y's both up on the top. So that would be an e to the x times a y plus 4 on one side and a 2y on the other. Now the goal is to isolate y, and I have it showing up twice, and once is inside a parenthesis. So the next thing I'm going to do is I'm going to distribute so that I no longer have a parenthesis. Now, just like I've done and practiced multiple times in section 3.6 with implicit differentiation, I'm going to see that I have two terms here involving y, and I have one term that does not involve y. So I'm going to put the things together that have y's and the things that don't have y's on the other side. So the most efficient way to do that is to move this one to the other side. Now, just like I did in section 3.6, I'm going to factor out the y so that it's written only one time. Now, because it's written once, I can isolate it. So I'll get y equals that 4e to the x on top and a 2 minus e to the x on the bottom. Now that I've isolated y, I can relabel it as f inverse. And I am done. Now I think on my answer key I have negatives all the way through. So I just multiply the top by a negative and the bottom by a negative, so either one of those would be correct. Okay, final step D is we want to take the derivative of this function that we just found. So the inverse's derivative at x will be low. I'm going to do the derivative of this one, d high minus high d low over low squared. So if we look at this now and we want to see the point breakdown, remember it's a free response, it's worth 9 points. So in part A, we get 2 points for the for finding out the domain. 1 point comes from writing that we know the inside of that log natural needs to be positive. So that'll give you 1 point. And then determining what the actual domain is gives you your 2nd point. On part B, to find the value of the derivative at x equals 2, this is worth 2 points. 1 point for taking the derivative, so you could either have it written this way or this way, I don't really care. And then 1 point for evaluating at 2. So that would give you your 2 points. 1 point for the evaluation, 1 point for the derivative. For part C, we have 4 points available. We get 1 point for switching the x's and y's. You get another point for getting rid of the log and turning it into this step. You get a 3rd point for multiplying and then factoring out. So if you can get to here, that's your 3rd point, and your 4th point is the final answer being equaling to your f inverse. So 4 points for this one, which means we have 1 point left for applying the quotient rule with the chain rule as needed.